Okay, now it is 1 o'clock in the Central Europe, 2 o'clock here in the most eastern parts, and I guess 12 o'clock in the UK, Portugal. So welcome everybody to this evaluation results webinar of the NordicWay 3. We have pretty tight schedule, so I'm not waiting any extra minutes for anyone to join. So we have an interesting session ahead of us. Here you can see the agenda. Unfortunately, I am not Anna Shirokov, who was supposed to be the moderator of this session. She is ill, and I am Satu Innama from VTT, and I will do the moderation on her behalf. So today I will first make a brief overview of the evaluation activities in NordicWay 3. Then after that, we will have 5 interesting presentations. They will each be 15 minutes, and then they will be followed immediately after this short, like 3-minute question and answer session. Please use the chat box to place any questions that you might have. If we get more questions than the time allows answering them after the presentation here in the webinar, to provide responses to your questions. And the aim is to finish the session 14:45. And then there will be still one more session of the webinar before this ends. So going forward. So now I'm moving on to this brief overview of the evaluation activities in NordicWay 3. Well, NordicWay 3, as the name kind of hints, is building on the activities done already in the NordicWay and NordicWay 2 projects. So also we have had evaluations conducted during those previous phases, and we do not repeat what was done, but build on complement the findings and research and different trials to really see the views or to find out different aspects of CITS. Now in NordicWay 3, our evaluation focuses on ecosystems, which remain to be one of those big open topics after NordicWay 2. So it was challenging to find ecosystems that would be able to providing these services. Other focus points are the user acceptance and HMI. We have topics related to socioeconomic impacts, and also about the feasibility of CITS service provision in the Nordic countries. And this includes also aspects related to the technical feasibility, related to sufficient quality of service, and these kind of aspects in addition to the ones above, so that obviously for feasibility we need to find viable ecosystems, we need to have acceptance, and we should have positive socioeconomic impacts. Single evaluations were carried out in NordicWay 3 in different deployment pilots across the project, and this means that they had the freedom to choose topics that they felt that were the next big questions that needed to be answered. So there were some systems which had been researched and developed more earlier than some others. So for some it was really finding those last remaining questions, and for some other services it was more going first to the more basic questions. But anyhow, they had the freedom to address those topics in the evaluation that they saw most important for the deployment of CITS. We had some joint evaluation topics related to roles and responsibilities and costs in the implementation and operation of these services. So we wanted to understand more these. These evaluation activities are still ongoing. There will be evaluation result deliverable. It's not ready yet. We will be there summarizing all these evaluation activities carried out under NordicWay 3. And as there are so many, we cannot compile everything in one report, but it will be more like some So if you want to know all the details, then you can easily find what is the report where these are reported. We will do also, or we will report the findings of joint evaluation topics. So as I mentioned, these are related to the roles and responsibilities and the costs. Obviously, we will also make this kind of discussion and conclusions across all the evaluation activities carried out, and we will make an overview. So overall, what did we learn after Nordic Way 2, and what if there are any open topics still after these years of Nordic Way 3? So what still remains to be unknown? This will be published in the spring 2024. So we will be a few months before we have finished this report. So this is very brief overview of the topics done in the past years, or topics covered, and then this report. And now it is time to go to our very first presentation. It will be done by Kaisa Weibul and Peter Smeds. Kaisa is a PhD student at VTI, and she also works at Swedish National Road and Transport Research Institute and Linköping University. Her research focuses on how ITS can be used to support drivers when interacting with emergency vehicles in traffic. And Peter Smeds is Senior Advisor at the Swedish Transport Administration. He works in the planning division with the area Vehicles Digitalization and ITS. So now I will hand back the control of the slides, and then guys, I hope that you can take over the control, or Alva can hand over the control to Kaisa and Peter.
I think if you share again, I could take control from that point of view. Okay, there we go. I think should be right. Okay, thank you for the presentation. I will hand over to Peter first.
Yeah, thank you very much. Here you can see a 2+1 road, and it has a wire that means that cars will not collide head-on with each other. Back in 1998, the world's first 2+1 road was inaugurated, and then it was a new technology. Since there were no similar road before, the Swedish Road Administration could not know what effect it would have. A kind of chicken and egg dilemma arose. There is an analogy in this situation with the digital services that are now being developed. In addition to ensuring that the service works technically, the Swedish Transport Administration also wants to understand more about costs and benefits in order to understand their effect. Today, the Swedish Transport Administration and VTI have worked with the digital service EVA, which can warn drivers of, example, ambulances. The goal is that the completed work should contribute to the Swedish Transport Administration's understanding of the effect a new digital solution such as EVA has. To understand that, we need to understand more about how the solution works, what benefits it creates, and what it costs. And Kaisa will tell you more about the research that VTI has conducted. And with those words, I'd like you to hand over to Kaisa. Please, Kaisa.
Thank you, Peter. Yes, I just want to start off with the basics here in the background, because EVA is a very important service to focus on due to the very difficult nature of emergency driving. Driving an emergency vehicle is very difficult. It sets a lot of pressure on the person actually driving. Of course, they need to often surpass the speed limit while driving. They have a very stressful work environment, and there's a high demand of the level and quality of communication, both with the patients, the other colleagues, but also the public safety access point. And even though it is very difficult for the emergency vehicle drivers, we still have the surrounding road users. And this interaction between those types of vehicles create accidents. And in Sweden, we have about 2 to 3 deaths per year with emergency vehicle accidents. And my understanding and to my knowledge, the civilian drivers, they want to do good. They want to move over in time, but they are not sure about how to do it and when to do it. And one way to support this interaction is to use emergency vehicle alerts or EVA warnings. And on the right here, you could see a design suggestion from NordicWay 2 that was designed by Volvo. And it is just to show kind of how it would look like and what kind of information it would bring. So the idea is that you will get an in-car warning 15 to 20 seconds before the interaction with the emergency vehicle so that you have more time to prepare and to move over in a safe and timely manner. Because lights and sirens today are not enough to make drivers move over in time. On the left here, we can see a very simplified version of the technical solution we used in NordicWay. And if I get my marker here, yes, we're starting off with a single emergency vehicle, in this case is the ambulances and the fire trucks. And via SOS Alarm, which is the public safety access point in Sweden, we have the current positions of all emergency vehicles in Sweden right now that are on prioritized calls, meaning that they are driving with either lights and sirens or only lights. In other words, life is in danger. So via SOS Alarm, we have the positions of all the emergency vehicles, but we also have the information about the final destination of the emergency vehicles, meaning that we via Carmenta Traffic Watch could calculate what the most probable path is. So we can get the information of where the emergency vehicle is likely to travel and therefore warn the drivers that are traveling on the same path. We then, from Carmenta Traffic Watch, took that information and put it into the CITS node that we've been using in NordicWay. And from that cloud, the OEMs, for instance, Volvo and Scania, who are in this project, could collect data about where all the emergency vehicles were and what drivers were affected by the emergency vehicle. And therefore, we can make sure that we can only warn the drivers who are actually affected by this prioritized mission. So to evaluate the possible effect on driver behavior with EVA warnings, we have been using simulators a lot in the NordicWay 3 project. Both more simplified versions, as the one you can see here on top, but also more advanced ones, as the one at the bottom. And there are various reasons to why we are using simulations. First of all, it is a safe environment where we can make sure that we are not putting our participants at risk. For instance, if we want to test out how drunk drivers behave, it's very, well, it's not that good to do that in a real traffic environment. So therefore, we can use simulations instead. It also ensures that all participants will experience the same kind of environment and the same kind of events. So if we want them to be approached by an emergency vehicle, it is easier to do that in a simulation. It is also easier to measure the driver behavior in detail. So for instance, their lateral position or the speed they're traveling in, and it makes it easier for us to evaluate the actual behavioral effects. And lastly, it is very practical when we are implementing a new system. So for instance, as Peter said, it could be a 2+1 road, but it could also be a new technical solution such as EVA. So I will now explain two different simulations that we did in the NordicWay 3 project, where we tried to see what kind of time could be saved with using the EVA system. And we had one very difficult situation where the drivers had to move over and one very easy way. So first of all, we had a countryside simulation or a driving simulator experiment where we had, I'm going to go back because we had this kind of simulator, more or less. And in this experiment, the drivers were driving on a very curvy and hilly road, and it was quite hard to see because there was a lot of trees around. And also they were listening to music as well, and they were in a bit of a rush. And in this scenario, we estimated that we could save about 30 seconds per vehicle that gets this EVA warning. Because this was a very difficult situation where it was difficult for the driver to actually move over in a safe way. So that is one extreme scenario, but it's not an impossible scenario, so to say. On the other end of the spectrum here, we have the highway scenario that we used. And there we had a three-lane highway with a flat road, and it was easy to see the emergency vehicle in time. And here we estimate that if you get the emergency vehicle warning, you would save about half a second per car, meaning that per car that the emergency vehicle had to pass, we can save half a second in response time. So these are two kind of extremes that we saw. And that is, so we can save time with EVA warnings. We then tried to calculate what that would mean in terms of economical value. And here, David Sundström and I have been trying to calculate what kind of, what we're talking about in monetary values. So the average response time in Sweden for a prioritized call is about 15 minutes. And if we look at one type of prioritized call, we have out-of-hospital cardiac arrests. And we have about 6,000 of them in Sweden each year. And one dissertation from looking at the Stockholm environment or the area saw that if we were to decrease the response time for cardiac arrests with 1 minute, we will increase the chance for survival with 0.7 percentile points, meaning that we will increase the chance of survival if you get to the hospital earlier. And if we were to look at, if we actually were to lower the response time by 1 minute for all of the out-of-hospital cardiac arrests, we estimate that we would then save about 42 lives per year. And if we look at this in just purely economical values, we could say that saving one life is estimated to be worth about 3.5 million euros, meaning that we will save society 3.5 million euros if we save one life. And in the NordicWay 3 project, we have calculated that running this kind of EVA system for a year, or per year rather, would cost us about €500,000 euros. So this means that if we are to save one life with the EVA system, we are bringing societal and economical benefit. But saving time is not the only thing here. As I mentioned in the beginning, we also have these accidents with emergency vehicles. And one common scenario for these accidents is the intersections, scenario or case. And if you listened yesterday, we had a presentation about the traffic signal priority, and that is also a very important CITS service in this, in this case, in this instance. But we also have, of course, the cases with the unsignalized intersections, and that's where EVA is very handy. But anyway, intersection is a very common kind of scenario for these kind of accidents. And the thing is that emergency vehicles, as you know, are allowed to surpass red lights if they have to. And the issue being here that the civilian driver here who has the green light will drive into the intersection and then they will kind of collide in the middle. So that is kind of the typical example of an emergency vehicle accident. So we performed one study here where we gave half of the participants an early warning that they had to stop before the intersection, and half of them did not. For the participants who received the warning, all of them stopped before the intersection here. And in the case of the drivers who did not get the warning, half of them did stop, but half of them did not. So they would drive into the intersection, and the emergency vehicle here, the ambulance in this case, really had to hit the brakes to avoid collision. So moving on to the conclusions, we can see that simulator studies can actually give us an indication of how these ITS services would work in real traffic. And there are life-saving benefits with EVA, both in terms of saving time, but also in preventing accidents. However, there are still challenges. First of all, we really want to test out EVA in real traffic in Sweden. And secondly, we still have to make sure that the digital infrastructure remains after the NordicWay 3 project, so we can continue on this journey with distributing the EVA warnings. Yes. Okay, thank you.
Thank you very much for the interesting presentation. We have one question in the chat box. So it was related to the saving costs. What is this 3.5 million per life based on?
Good question. It is more in economical terms. That is not really my area, but I know we have a professor here at VTI who works a lot with that. And it's about how much money can be saved. And that in terms of, I mean, it's kind of out of my area here, but that you save money in terms that relatives don't have to be on sick leave, and then the money you actually pay via taxes and so on, those kind of monies. I don't know if Peter knows anything else about this.
No, it's of course it's very difficult to say how much like a life is worth. It's basically impossible and priceless in one way, but you put the price on different things such as CO2 and different emissions to be able to value them towards different implementations of adaptations to the transport system. So if you, for example, want to build a safer road, you need to look at that, the cost of rebuilding the road towards what the savings are in the way of people not getting seriously injured or killed in traffic accidents. So, well, that's all I had to say about that. So.
I think Luna is correct here in the chat that it's clear here that we did not really make this up. This is a unit that is commonly used or a value that is commonly used.
Yeah, so it's the Swedish national unit price for one life, but I think they calculate it based on these direct costs of having somebody being killed, and then also this kind of losses that this person is no longer productive. So if a young person is killed, then it's not like loss for the society, so that in the future this person is not productive anymore. Yes, thanks. I think we can have still a question or two. So when you use simulators in these in your study, and you studied this ERA service, but how could you generalize anything about how would the drivers react to other warnings than related to ERA based on your findings?
I would say that we can kind of generalize to some of the other warnings that we have in NordicWay 3 projects, such as the roadworks warning, but also the accident zone warning. I think we will kind of see the same results here. However, we did a survey study now with Swedish drivers, and we got about, I think, 1,400 responses. And we could see that EVA is the service that is valued the highest. So people think that that is the most important service, but I still believe that we will have kind of a similar results with the roadworks warning and the accident zone warning as well. Okay, thanks. So this is the top one then. Yes. Acceptance. Very good. Then another question. So how do you see, what are the next steps in implementing this service to be a real service deployed in the transportation system?
Yes, I would say that what is important now is that we find an actor that will take this role to host this software and this ecosystem that is required to make this happen. And another important thing is also to work with the vehicle manufacturers and their service providers so that they actually implement this signal into their user interfaces in the new modern cars. I think those are the two main important things right now. Thank you.
Okay, thank you, Peter. So there is a good service looking for somebody to host it and to deploy it. So,
yeah, and to pay for it.
To pay for it, to be also practical. Thank you very much, you two. I don't see any other questions in the chat box, so thank you very much. And then it's time to move to the next question, which is related to the evaluation of societal benefits of CITS in traffic signals in Uppsala. And we have again two presenters. We have Martin Legend. I'm sorry for not being able to pronounce your name correctly. You may correct me later. He is consultant of smart mobility and public transport at Godapel, and he likes the tension between existing and innovation and of all different perspectives that people have on it. And he applies system thinking to his work. And then in addition, combined with him, we have Sampo Inemo, who's traffic planner at Uppsala municipality since 2006. And he has worked with public transport, infrastructure, traffic signals, and CITS. So now I see that you have the slides, and I hope that everything is working fine. So now the floor is yours. Thanks.
Thank you, Satu. We'll start the presentation with a little introduction, and Martin will then go more in detail in the results. In Sweden, many road authorities doesn't know so much about CITS and what benefits it could bring and how it works. We know we have a lot of experience for signal priority that could be there's a standard for signal priority, but we don't have so much experience about time to green, time to red, and GLOSA. So for a larger or a middle-sized city in the Nordics, what value can a variety of CITS services bring in the future? Is it realistic to expect positive effects from CITS in the short term, or is it more a long-term investment that is needed? And what kind of investments are necessary for a road authority to implement a large-scale CITS services? These are questions that are addressed in this project. The studies that have been carried out by Hodappel, where Martin works, have given us as a city more insights, and we have worked together with RISE, City of Gothenburg, and Stockholm also. And you all already got an introduction of us, so I just continue to the next slide. In Uppsala, we have many objectives related to traffic planning and city planning. And one is that we have to use space in a more efficient way, and therefore we try to prioritize pedestrian, bikes, and public transportation in the central city. Sometimes we would like to prioritize heavy vehicles on pointed out thoroughfares, especially if there are non-residential areas along the road. We work with we try to lower pollution in whole city, and we also try to reduce wear and tear of the road surfaces by making cars, especially heavy cars, vehicles, brake and accelerate not so often that they do today. The studies have been done by microsimulation, and Martin will tell about that more. But there are 3 locations where the studies has been conducted with a little different characteristics. And one is a solitary intersection south of the city center. One place is a corridor or a thoroughfare east of the city with a green wave. And then we have in the city center, we have Kungsgatan, that means King Street, where bus priority has been studied. And in the solitary intersection, time to green and time to red and GLOSA has been studied and at the corridor of the green wave, there has been studied of GLOSA. So, and here you can see on a map the location of the microsimulations in different kind of environments, and we have tried to find environments that could be typical for a Swedish city or in Finland or Norway or Denmark. So we'll also try to compare results and see if we can find same kind of results of if there are differences. Martin, I think you can take control now if it's.
Yeah, thank you, Sampo, and thank you, Satu, also for the introduction. My last name is Lejeune. It's a difficult name, but it's okay that you didn't pronounce it correctly. I will talk about the results indeed in Uppsala. What we mainly wanted to achieve is to gain realistic expectations on the impact of CITS on intersections. What we see from the simulation, we carried it out in Vissim, and we varied multiple variables that explain how CITS could work, how the road users can interact with the traffic lights. But we see there that there is overall limited impact based on environmental KPIs, but there are some improvements possible on the environmental KPIs. However, this is compared to a system that's already well functioning. In Sweden, you generally use, or in Uppsala at least, use vehicle actuated traffic signaling. And because of difference in speed, it's promising for hybrid cars. I will go into that later on as well. Compared to a single intersection or a corridor, we see that the impact is strengthened on corridors, and that indicates that it's important to scale up the solution. So not only have it on one intersection, but have it in a string of intersection and possibly some intersections that are connected with each other. And stops is there not the most important KPI, because fewer stops do not necessarily lead to lower environmental impact. Also, a lower average speed could be less emission friendly, which you can see on the graph on the right. So think about the energy consumption. And because, for example, the average speed could go down, we did not calculate what the impact of hybrid cars would be. But for example, if a car is able to drive electrically when it's driving 30 kilometers an hour, and on fossil fuels when it's going 50 or 60, there could be additional gains to be made there. But for now, all the cars were just the current vehicle fleet in Sweden. And that means, as you see on the right, that if you drive slower, the amount of fuel that's needed per kilometer could actually increase. I will go into more details here. What you see here is that we see the biggest impact on the number of stops on a solitary intersection. Maximum reduction of 8% when we implemented time to green or time to red, what you see on the left side, and a possible decrease of a higher possible decrease when you implement closer. And this is compared to a situation with no information. But even though the stops could change, we see very limited impact on the travel time or on the environment. And this is because the information of CITS, they are meant to slow down cars while driving. Speeding them up would actually encourage speeding. So therefore, we also see that there is a possible negative impact on travel time if you implement smart solutions into your traffic signals. However, knowledge about start time or when the light becomes green, that could reduce the reaction time by approximately half a second. But that's mainly only for the first vehicles that have to leave an intersection. The main conclusion from this slide is that fewer stops do not necessarily lead to lower environmental impact. So do not only think about the reduction of stops, and a lower average speed is possible also less emission friendly. But when we scale up.
Yeah, sorry, we only see the slide 23 still. So I think you were already further down your presentation.
Sorry. You did not see this slide?
We still see the number 23.
Then it doesn't work here. Can I share my own screen maybe?
Now we can see it, yeah.
Yeah, perfect. I'm sorry, I was just explaining this slide, where you see the biggest impact on the number of stops and limited impact on accessibility or environmental KPIs. I will still continue though, because on the previous slide, you saw almost no environmental impact on a single intersection, but on a corridor, emissions could improve. So it's important to scale up the application. Here you can see that there is a bigger impact on CO2 or NOx that's measured into the simulation study. However, we still see no significant effect on travel time, and a slight increase on the number of stops is also possible, or a slight decrease in the travel time is possible because of a shorter cycle time in the entire intersection. The third use case, as Sampo explained, is in the city center, close to the central station of Uppsala, where we implemented bus priority in Visim. And bus priority improves the traffic flow of public transport. Up to 50% less travel time loss per intersection is possible. And that could mean a 10% reduction of the travel time of public transportation going through it. And this means 1 or 2 minutes travel time savings per bus line, which is both nice because you can be quicker from A to B, but also it has planning implications. So possibly make it easier to implement a schedule if you have a few minutes extra flexibility. We implement this with minimal negative impact for other road users, which means no extra travel time loss for slower modes, such as biking or pedestrians. and maximum 6% extra travel time loss for cars we allowed in the city center of Uppsala. Conclusion here is the impact of CITS is bigger when you use it to prioritize and optimize traffic compared to only informing traffic. Additionally, there are some soft benefits of CITS. We did not get them directly out of the simulation, but you can logically reason that this would happen as well. Improving user experience could happen because you improve driving experience and more comfort. For example, if you need to slow down less, it's more comfortable to drive. This also means that the car could become more popular. So cities should also ask themselves, is this what we want? In certain locations, it could be what you want. But if you talk about the city center, maybe you should reconsider increasing the popularity of cars. According to safety, access to more information leads to better anticipation and improved reaction times. And this could reduce the likelihood of accidents. And more harmonized traffic leads to less speed differences and less taking over. And for the environment, fewer stops not only lead to less emissions, but also to less acceleration and less deceleration. So it also is a bit more friendly for the tires, and it has less noise for people who live close to intersections. From all of our simulations, we consider many different variables that we implemented in order to simulate how CITS works. But not all of them play an important role in societal benefits. Factors that influence the success of CITS are the number of vehicles with the CITS connections, which is called the penetration rate when you look it up in literature. The traffic load when you implement it, is it on the morning, is it on the rest day, is it in the night when there's less traffic? The type of traffic signaling is important. Is it fixed or is it vehicle actuated? On a corridor, it's important when you give the advice. So if you give it short to the intersection, the impact is much less than if you give it from a longer distance. And the directions of the road on which you give the information is important. If you do it only on the main through traffic, or if you also give the side directions some information. And on the right side, you see a few factors that we found from literature that should have an impact, but in our simulation, they did not have any significant impact. So we left them out of scope for the future of the study. And we did not only include this in Uppsala. Tomorrow, there is the Polis conference in Leuven in Belgium. And there we will present the results of GLOSA in Göteborg. And yeah, there's similar results as in Uppsala, but that doesn't mean we should neglect them. Every percentage of impact is important in a challenge to emission-free transportation. And GLOSA could be used as a driver to set up multiple CITS in the future. And if you want to know more about that, you can also see us at the Polis conference for who is going there tomorrow. Yeah, so it's important to consider CITS also as a pioneer application. So yeah, make the system work and then you can connect future applications to that later on. And lastly, this is my last slide as well. All of the information I just gave you is available on the guideline. You can use this QR code to access the guideline, or if you can find the PowerPoint slides, you can click the link that is on the right top. Either way works. And this is a guideline for cities on how to implement CITS on signalized intersections. And if you want to know more, please reach out to one of our project members, which is Sampo or me or Johan Östling, but also from the municipality of Göteborg. We're glad to tell a little bit more about this project later on. So here's the last slide. We now understand the challenges of road authorities by operationalizing their goals. We understand the general potential of CITS in terms of KPIs. There is location-specific potential of CITS according to determinative conditions, such as the behavior of road users and local characteristics. And by that, we could calculate the cost and benefits of CITS on signalized intersections, which improves our understanding of the challenges even more. Thank you for listening.
Thanks a lot, Sampo and Martin. So just a hint to Peter, there was a question for you in the chat box. So if you scroll up, hopefully you are still online and can answer that. And then Alva, if you could put up also now the master version of the slides for the next presenter. But let's go. We have a few questions in the chat box. First question, in the GLOSA emission impact, did you consider the crossing traffic as well, or only the emissions of the vehicles in the main direction?
We considered the emissions of all the vehicles that were in the simulation, so also the crossing ones. And possibly they had to stop a little more often than the others did. So we considered all of them.
Thanks. Will there be more harmonized traffic also in the mixed traffic of CITS and non-CITS equipped drivers?
An academic answer here is it depends. No, there could be more harmonized traffic because enhanced communication also leads to better anticipation for a few road users that are there. But we also considered that maybe people don't understand what the vehicle in front of them is doing because the light could be green, but the car is still slowing down because it's soon becoming red. But the cars who do not have that information, they maybe don't understand what's happening around them. So therefore, it's very important to not only focus on the vehicle that receives the information, but also to the rest of the vehicle fleet that, doesn't get the same information. So we did not calculate that in much detail, but we described it that it's a very important point of attention, yes.
Yes, okay, thank you. And then one still question about your estimate of CITS penetration rate now and in the near future in Sweden and in other countries. So what's your view on the knowledge on these or estimate of the penetration rate here in the Nordics and elsewhere?
I think we have to ask the OEMs. And since we don't know, it could be 40%, it could be 100%, it could be 0%. We included all the different ones in our simulation to see when you could reach the successes and when not. Okay. So on this question, my answer is, I don't know. I hope the OEMs has an answer.
Okay, but you covered them all. So in that sense, no matter what it was, the answer is out there. That's very good.
We could provide information on all of them by varying this.
Yeah. Then there was a request or hope for you to provide the link to the study also in the chat box so that people could reach it right away.
Yeah, I will do that now.
Okay, thank you very much. And that was really an interesting presentation. But now it is time to move on. And we will hear about evaluation of geofence implementations. And the presenter will be
Satu, sometimes you fell out, so I didn't hear what you were saying now. But anyway, thanks for the introduction. I'm going to try to take control here and then move on to the next slide. My name is Ørjan Tveit from the Public Road Administration in Norway, and I'm going to talk about some of the evaluation we have done of geofence implementation. I'm going to talk briefly about 3 different projects, but all of our project has been documented and evaluated through research projects, mainly at by SINTEF. But as was said previously, I think that they will all be documented more thoroughly in the evaluation report that will come the next spring. Just to be clear, do you hear me, Satu? Can you confirm? Okay, that's good. What is a geofence? A geofence is a virtual and geographically placed zone. For traffic management, it's possible to add rules, requests, or information to these zones, communicate them to the vehicles, and control the vehicles or inform the drivers. The vehicles can also share data back. We can say that's only your imagination that's the limit. So you can, for example, ban all red cars from the city. that's more like a theoretical view, but I think this is something that you can look into. The first survey that we're going to talk about is a management of hybrid BMWs. BMW allows local government to define low emission zones and automatically shift the cars towards electric drive when hybrid BMW is entering the zone. So the Public Road Administration defined low emission zones in 4 Norwegian cities and asked the drivers about their experience. There was a mixture of how people were reacting, and that means that that means 59% of the drivers that we interviewed had actually seen that their car had changed, so that they shifted to electrical drive only when they entered the low emission zone. And then again, you can say that most of them were driving a lot in the city centers, and 41% have never ever noticed that the car shifted, and that mainly because they didn't drive in cities. That's a perfectly good reason. We asked the drivers if they accepted the eco-friendly functionality, and also if they changed the behavior of the car back to dual mode. And we see that only 4% are annoyed or irritated by this functionality and shifted back to dual mode, but most people were appreciative of this new functionality because they made their cars be more environmental friendly. And this demonstrates that it's possible for authorities to make use of technology in advanced vehicles at lower SAR levels by defining the use of these to be voluntary and to allowing the drivers to switch off the functionality if needed. You see that when we asked the drivers how they perceived what we did, we saw that the people who had noticed that we have shifted the use of their car, they were much more friendly to thought that this could help both them and all drivers to drive more environmental friendly. We did another survey with road user charging, and this was more like a gaming setup, because we took hybrid cars and said that they should try to drive electrical in city center, and we used the gamification by saying that if they drove electrical, the fee was 0. If they drove by the diesel or whatever they were driving by, the fee was 3 Norwegian kroner per kilometers. So that means that they had to pay if they were driving non-electrical. But as a gamification, they started with an account of 1,000 kroner, and then they decreased based on how they drive. And the gamification was that when they finished with the test in 2 months, they will get the money that was left in the account. But by exploring the technology in a voluntary use case, it's possible to gather experience from the drivers based on the use of the system in everyday life, making it a large-scale data collection, so that people have actually tried how the technology could work if it was installed. And that's a much better starting point from asking about how they perceive new CTS solutions. So quite naturally, a lot of the drivers were very positive to this sort of road user charging because they could avoid it. So when they said if they only were driving by electrical all the way, they would have no cost, and we saw that they were quite positive to anything that we asked them about when it comes to how they perceived it and so on. It's more documented in a research paper that will be more thoroughly described in the evaluation report. Another third survey that we did was road user charging, where actually there was no free ride like the previous one. We have defined a price zone in the city center of Trondheim. We defined higher prices during rush hours, and we had 126 participants in a use case where we try to get information about how we can replace tolling station with distance-based road pricing. We had a pre-survey that was sent out immediately after equipment installation, and then we had equipment in the car that registered where and when you were driving, so that we could explore any changes in how you were using the city and so on. And then we had a post-survey 2 or 3 months after installation, exploring experience and attitudes toward the tested technology. The attitude towards the current tolling system is not totally favorable. As you can see that a lot of the drivers thought it's quite unfair, and that is because the ones who are living inside the tolling ring doesn't pay, and those who live outside the tolling ring and have their work or school inside the tolling ring, they pay the most. And I think that was something that were reflected in the way that people were judging how useful our road user charging could be. But most people were positive. But the last question, has it helped you to save money? Of course it didn't, because we tried to make it equal, so that the right road user charging and the tolling should get in the same amount of money from the people who are abroad or part of this test. But I think that this was a nice way of getting information about how we could use road user charging and what people are focusing on, what we should improve to get it better. And my final slide today is the takeaway. Trials or piloting studies are often conducted under limited circumstances, such as time and location. By introducing new functionality as a voluntary test, more drivers will experience learning, and this will over time influence how they experience being regulated automatically by digital traffic laws. It means that if you're tested a new functionality, you're more likely to have an informed answering on how you will perceive it if it actually will be implemented. And you can also give information about how it should be altered or how it should be developed further to be better. Voluntary use cases are examples of how authorities could move forward in terms of using adaptive policy making, since voluntary policies are more flexible and easier to adjust over time as experience and knowledge about use cases is brought forward. And that was the final slide. And any questions?
Thank you very much. I hope that you can hear me now. I had some technical difficulties in the introduction, but luckily you were self-controlled and you were able to, or understood that now is your time to set up. Thank you very much for handling it. Now, if there are any questions, please place them in the chat box. While waiting for them, I could have a couple of questions. So in Norway, you are doing very much of this learning by doing type of approach. So what do you think are the biggest benefits in this kind of just trying it out in practice?
I think that it's a good way of learning how people react to it, but we have the same problems that you do in Sweden and Finland, because we tend to do a lot of piloting, and it's difficult to move from piloting to implementation. So it's a different way of studying how people would react to new functionalities.
Yeah, that's right. How well do you think that those participants of this kind of pilot reflect really the whole population in Norway? How represented?
That is, of course, one of the issues, because we have a tendency to have a lot of guys in their 50s to be interested in participating, because it's so easy for them to be focusing on technology. So that's something that we have to work a lot with, to have both balance between the genders and also between different age groups.
Yeah. Very good. How much in average does a driver pay per day, per year here? I guess related to the road pricing.
That's totally dependent on where you are living and how you are set up. But I think that something like 5,000 or 6,000 is not unusual. Some are paying a lot more based on some sub-sea tunnels and so on, but that's not the regular case.
So that was Norwegian crown, 5,000 or 6,000 Norwegian crown.
Yeah.
Okay. Thank you. Were there any issues with privacy among the participants when you did your study?
Privacy is, of course, a huge issue with all sort of new functionality. But I think that when we have this sort of test, we normally have compliance from the test users, so that we can evaluate their driving and their paths and so on. Otherwise, it's impossible to do some studies from it. But when it comes to implementation, it would be, of course, really important to have the privacy. So that means in the first study from BMW, we didn't know how much people have been driven and how well they have been driven. We just asked them, we know that you have a BMW that is changed now. Can you tell me something about how it reacted? And then we had our questions to them.
Yeah. Different ways of how to overcome these privacy issues in the study. Thank you very much. I see now no further questions. I guess it's time to say thank you once more to Örjan. That was a very nice presentation as well. And then we will continue to the next presentation, which is related to acceptance and need of real-time traffic information services in the transport industry. This is a study coming from Finland. And my colleague Esko Lehtonen, who's a senior scientist here at VTT, will do the presentation. And I hope that, Esko, you are able to take control of the slides now. Thanks.
Looks like that if you see the title slide.
Yeah, we do.
Okay, thanks for the introduction, Satu. Yes, the topic is the acceptance and need of real-time traffic information service in the transport industry. This is a study which was made mainly by Arto Laukkonen, my colleague from VTT, and we had also some other colleagues supporting us. Thanks for them. So, what was the aim of the study? Previously, CIT studies have focused on car drivers, and this time we wanted to understand the views and needs of the professional drivers, transport coordinators, and CITS service providers in the field of freight transport. So everybody probably knows what are professional drivers, those who are driving the actual trucks and vans. Transport coordinators are those who are coordinating and organizing these transports at the companies. And service providers, of course, are the producers of the services. Here we had some more specific research topics. So we wanted to investigate acceptability of day 1 and day 1.5 CITS services. We wanted to know willingness to participate in CITS service production and service use. And then we were interested also in the capability to utilize information from CITS services in logistics in general. What kind of development ideas the stakeholders could have regarding the services, and which factors encourage the interaction and continued use of CITS services in the field. And also, we were also focusing on this kind of question that what kind of spatially and temporally bounded information is relevant. So that could be, for example, some sort of weather warning, which is very specific to some location. Let's say that warning that this bridge is now slippery. We used the following methods in this study. We made an internet survey to professional drivers. We got 79 respondents. It was a little bit difficult to reach those professional drivers first via internet survey, but via different kind of networks, we managed to get quite a nice response rate after all. Of course, it might be that this sample might be a little bit biased to those who are more technologically oriented drivers. Then we also made some phone interviews with transport coordinators and with the CITS service providers. That was complemented with a literature review and impact assessment procedures. So here are some highlights of the study. So one of the key questions was what kind of information is important for the professional drivers. So we asked them to rate the importance of different kind of information types. Basically, they were formed based on this CITS day 1 and day 1.5 descriptions. There was many of them. And we also asked them separately considering summer conditions and winter conditions, because there's quite a difference between those. Because we had so many information types, it was easiest to categorize the answers, and then we calculate the mean values for the responses. And we ended up having 7 categories. This is kind of first is information about the estimated time of arrival and what is the status of the destination. For example, is a harbor area very congested or something like that. Second one was attention guidance, was like driver alerts. Then there was information about the service stations and rest areas. This is, of course, something what is already quite readily available in some app applications too. Then it was speed guidance, for example, information about the current speed limit, driving route, that refers to not only to the route guidance in sense of navigation, but also information about the weight limits or maximum height of the truck. Then there was weather and driving condition information. This is quite self-evident. It's of course weather. Is the road slippery, etc. And finally, there was 7 category hazards. That means, for example, if there's some accident ahead. So here we see that basically all the categories were rated quite important. They were all above 7, which was in the neutral. And overall we see that in the winter conditions, all the ratings are a little bit higher, but especially for the winter and weather and driving conditions and for the hazards. And also we can interpret that those kind of more safety critical things like weather and driving conditions and hazards are maybe rated the most important. Also, this driving route information is very relevant, one of the most relevant in both in summer and winter conditions, and that of course can be explained by the fact that it contains information about the weight and height limits, for example. So we also asked their experience usefulness of CIT services. So sorry about the font is a little bit small, but you can see there that they were mostly rated quite useful. And the top most important thing based on here is the safety of improving the safety of my transports. But there's no that big differences here in these different dimensions. They range from, they are like safety, smoothness, comfort, efficiency, energy efficiency, avoiding congestion, and punctuality of transports. The professional drivers were quite open for sharing information from the route and vehicle to the services, and they already had some real-time information systems in use, especially about the speed limits and information about the route and hazard warnings, but maybe not so many after all. So how are the views from the transport coordinators? They are of course looking at the same thing from very different perspective. So they agreed with the drivers that information on hazards, weather, and driving conditions are very important. Also information about the driving routes. And they especially considered that this kind of real-time information about the route can decrease the delays and detours needed. And that, of course, improves cost effectiveness and functionality of the transports. For example, if some bridge or tunnel is closed, and that means that the transport need to take a longer detour, that can be quite bad for getting to destination at time. If you need to reach ferry, for example, or harbor, so that you can get your cargo on time to the ship, that is can be a very bad situation if you miss that. And what was interesting that transport coordinators did not really think that many services are used by the drivers. Well, partially that's true, but overall, maybe the professional drivers were more like indicated that they already have some services in use, and the transport coordinators did not really know exactly what kind of services the professional drivers are using. Of course, all the logistics companies have some of their own systems, like GPS tracking of the vehicles, etc. But they are not really CITS services as such. Then we had also interviews with service providers who are actually providing some of the services. They told us that the most wanted services are localized and relevant warnings, information about the road surface conditions, especially on slipperiness, weight and height limits on the routes. So those kind of things which really matter for the safety and for the efficiency. They also indicate that this kind of public road infrastructure database is available. They are useful, but the information often is missing or outdated, which makes it more difficult to implement a good service, to provide a good service. And they also indicated that they would like to have open discussion between public sector and service providers, especially when there are some projects or plans to start operating some sort of services. Maybe they felt like that they are doing something and the public sector is doing something on their own kind of areas. The service providers felt that stakeholders in the field are willing to share information if they benefit from it. but this GDPR and data anonymization is always something what requires quite a lot of resources. So yes, we are coming to the summary. So to be considered useful, CIT service must provide relevant extra information in addition to what is already available. Some real-time information services are already in use, but the services are not yet based on the CITS infrastructure. That was one of the observations at the moment. So they are more like map-based information, or which might be like manually inserted to the service. The importance of the services are more prominent in winter conditions and in other difficult conditions for the drivers. And the challenge for the service providers is to offer high quality and spatially well covering data in a cost-effective manner, because they often have to, for example, collect the information from the road conditions by themselves, and that might be difficult if you don't have large resources. The public databases about the infrastructure are in use, but they are not always up to date, which kind of contributes to this challenge. And integration of CITS services as a part of route planning and transport coordination could be some topic which could be investigated more, and there might be also some kind of possibilities for further benefits. So thank you for your kind attention, and here's my contact details, and there's a report available, unfortunately in Finnish, but luckily AI systems are getting better and better. So if you are really interested, you can give it a try. Thank you.
Thank you very much, Esko. So now room for a couple of questions. Feel free to type them still into the chat box. So there is a question: did the drivers also get real-time information with respect to free loading on unloading areas?
Good question. Now I have to really try to remember what kind of categories we had. I have a feeling that we didn't have that kind of information type in the surveys, and I think the services they had EUs already that didn't contain that information.
Okay, thanks. So what are or what would be the most interesting further research topics in this field? So this was done 3 years ago, and what would be the next questions to try to answer with research?
Good question. Well, first of all, I think one of the things what we could what would be interesting to have a look is to maybe do a little bit more in-depth interviews with the professional drivers and service providers and also the transport coordinators. One of the challenges was there also that it was during the corona pandemics that we couldn't really arrange like face-to-face interviews. And one of the things what it would be now maybe more interesting to have a look at how this kind of CIT services and automated driving systems might be collaborating and supporting each other in the future, because this kind of automated driving in freight transport, it's kind of very attractive, of course, for the logistics companies.
Yes. So now question from the chat: do you think that the service would be useful?
What kind of? There were many kind of services, and maybe I don't know, does it refer to some exact service? So real-time information about the free unloading areas. Okay, thanks. Yes. I guess if it's something that is, well, if it's something that is relevant for the drivers, then it would be very useful. I guess it might be also depending on the type of the transport. And for example, that if there's some kind of, if it's uncertain, if there's a free unloading area or loading area, and you have to look for that, then it would be really important for the drivers to get that information. But maybe some cases, if you don't need to really kind of find one, you just kind of go to your destination and you know that you can unload and load there, then it is not so necessary. So that kind of maybe highlights the thing that what is relevant for who, it depends also on the context and what kind of transport they are doing.
Yeah, definitely. They're very different if you are in a small place compared to a large hub with a lot of transport going back and forth. Very good. What do you think that you mentioned this automated driving, but how do you see that the driving automation would influence the use of CITS service in the logistics sector?
Yeah, it's of course ultimately if all the trucks would be driverless, then there would be no need for CITS services for the drivers. But I guess the future will be more like some sort of hybrid version that they are also drivers and then automated trucks. So one of the things what I could think is that it might be that automated driving is limited with its ODD. For example, maybe it can't really drive very safely in a slippery conditions. So maybe the service could provide information for the automated truck that okay, it has to issue this kind of takeover request quite soon, and it could also alert the driver. So that could be something very essential, is kind of almost a part of the automated driving system. But that is maybe a little more like in these situations where the automated driving system is still kind of requiring human assistance, human driver present in the truck. Maybe if we are really talking about the driverless trucks, then we have to really consider this kind of whole infrastructure again. What is the role of these services there?
Yeah, maybe slightly different services than as like part of connected vehicles in that fleet, perhaps. Thank you very much, Esko. I see no further questions in the chat area. So time to move on to our last presentation. So now we will until now we have heard about CITS, and the next topic is related to automated driving. So it is also in the scope of NordicWay 3 project. And Elina Aittoniemi, who is a senior scientist here at VTT as well, will tell about evidence on impacts of road transport automation from the Nordic perspective. So Elina, the floor is yours.
Thank you, Satu. I hope you can see my slides now.
Yes.
And yes. Yes, so the study that I am talking about, it had two main objectives. One was to provide an overview of the potential impacts of road automation. This was done by reviewing scientific publications. And the other objective was to assess the applicability of these results in the Nordic context. That was done with expert assessment and workshops. The study focused on road automation through 4 use cases and 5 impact areas that we studied. So the use cases were passenger cars, public transport, robotaxis or shared automated vehicles, and automated logistics and platooning. And the impact areas were vehicle kilometers traveled and modal split, so the amount of travel and travel behavior, traffic flow in terms of travel times and capacity mainly, environment or CO2 emissions, safety, and interaction with other road users. The main focus was on higher level automation, so levels 3 and above, but also some lower level studies were included. And the main focus was on the literature from the past 5 years. And in this study, we defined what we defined as the Nordic context. We recognize these following issues. So we have the quite harsh winter conditions in many months of the year. So there is snow on the roads and snowfall and ice and anything else that usually automation is not handling well. We have long distances between cities, or at least in Norway, Sweden, and Finland, we have large countries and small populations, so long distances between centers and between the south and the north of the countries. Short motorway networks and rather large share of two-lane roads, low traffic volumes, and then there are high labor costs for drivers. And then in addition, also other trends that are global apply here, for example, urbanization. So next, I'm going to briefly present the main findings from each of the 5 impact areas and then give some overall conclusions. First, regarding the vehicle kilometers traveled and modal split. So the amount of the automation in cars can reduce the value of travel time, which can lead to more travel taking place in personal cars, so increasing VKT and the mode share of cars. Robotaxis or shared automated vehicles can either compete with public transport or supplement it. It depends on the deployment model and incentives that are in use. And research goes in both directions. And there's potential for automation to improve the cost effectiveness of public transport and freight transport. Then regarding traffic flow, it has mainly been studied through simulation because there are not enough automated vehicles on the roads, and they often use quite optimistic assumptions on the capabilities of the automated vehicles, for example, using very low gaps. And with the low time gaps, the road capacity improves in the simulations and travel time decreases. But in reality, it's not clear if those gaps that are smaller than those of human drivers are feasible, at least in the short term. And a lot of the research on traffic flow impact has focused on congested situations on motorways. So there's less known on lower traffic situations and also less on the travel times in urban areas. Then regarding CO2 emissions, so generally the emissions from road automation, the emissions from road transport depend on the amount of travel, so the vehicle kilometers traveled and the emissions per VKT, and automation can affect both. And also for emissions, as for traffic flow, the impacts have been mainly studied with simulations, but also some on-road or test track studies have been done with lower level AVs. And the findings suggest that driving behavior of automated vehicles can be more efficient than that of human drivers, especially in steady state conditions. So when the traffic is stable and there are no disruptions. But the conclusions for disrupted traffic are more contradictory, and research points towards negative effects in these conditions. And real world disruptions are very common. So there are always many types of road users and gradients and weather conditions and all kinds of disruptions present. Then regarding safety, the main factors that affect road safety are accident risk, exposure, and the consequences of accidents. And none of the studies found considers all of these aspects. Automation can reduce accident risk of all use cases, and the size of the effect depends on the use case and the environment studied. travel behavior impacts may influence safety negatively. So if the amount of travel increases, then the exposure to accidents increases. And also mode shifts from safer modes, such as public transport, to less safe modes, such as cars, may then change the exposure to accidents. And the fifth impact area was the interaction with other road users. And here, after a lot of initial empirical work, research has mainly focused on theory building and conceptual work. There have been extensive studies conducted on external human-machine interfaces, but the results have been mixed. There have been some promising designs, but their role in the communication with pedestrians or cyclists has also been questioned. And what should be done next are working on standards and practices, technical design work, and new empirical work. So to come to conclusions, the studies that were found, they use a varied range of assumptions on automation and its capabilities, and they are not always made explicit. So all the assumptions that are made are sometimes not clear, and also the assumptions are not always related to the practical developments in reality, but are rather optimistic depictions of ideal automation. Most research has focused on personal cars and robotaxis, and there's less known on the impact of automated public transport or logistics use cases. Regarding conditions, most research has focused on motorways and dense urban areas, and usually ideal conditions are considered, so no bad weather or no road gradients, often even no heavy vehicles and other factors are there. So for these reasons, the applicability of results to the Nordic context is limited. Because we have less motorways and also urban areas are mostly smaller. There are trade-offs, for example, between safety, traffic flow, and emissions objectives, and it's challenging to improve all of these at once. There's a lot of research on these changes in amount of travel, so especially the vehicle kilometers traveled of personal cars and robotaxis, and how they change is crucial for the impacts on traffic flow, emissions, and safety. There's an increasing amount of research available on the potential impacts of automation, but it is mostly narrow in scope, so more research is needed to gain knowledge on impacts in a broader range of conditions and for a broader set of use cases, and then also apply that to the Nordic context. So this work is currently being finalized, and the report will be published later, and it will be in Finnish. And this was it.
Thank you very much, Elina. Yeah, unfortunately, Elina does not have camera in her laptop, and therefore you couldn't see her face. But anyhow, she is here in the same room with me. So we have one question here in the chat box. Did you get any numbers out of the simulations, like how much CO2 emissions or travel time could be saved? How big automated fleet would be needed to satisfy travel needs in the case of shared robotaxis?
Yes, indeed, there are a lot of simulations and studies done that provide numbers, but they go in very different directions, and it depends a lot on what they assume. So for some vehicles, if they are very, very aggressive in these congested conditions, then there are effects like many tenths or large percentages of emissions could be saved, but then they only apply to this limited context. And the same for travel time. So So I would say that the effects from literature go in a wide range in both directions, positive and negative, and it's so much applied. It depends on the use case and the assumption study that it's not really possible to generalize any results. And how big a fleet would be needed to satisfy the travel needs. There are also a lot of studies going in both directions. There are these, I think what is the commonly used study is, they say like about 10 to 15 vehicles, or one robotaxi could replace between 10 to 15, sometimes even 20 passenger cars. But that's a very, I think, also optimistic assumptions. So they only look at some type of travel and not, for example, holiday periods or anything like that.
Okay. Were there any traffic flow analysis made an impact of robotaxis?
That was actually quite surprising that I did not find many studies on robotaxi impacts on traffic flow and emissions, which is the ones that I was studying. So for robotaxis, it seems that they have been studied, especially in the US, but the impacts always come through the changes in the VKT. So at least the emissions impact come from there, and from traffic flow, I did not find many studies that would look at traffic flow. So yeah, there's also one area that needs more research.
So you said by VKT, and VKT means vehicle kilometers traveled, and you said that the impact came via VKT. So what was the assumption? How would the vehicle kilometers travel change with this kind of robotaxi service? Does it increase or does it decrease?
That also depends a lot on the study and what kind of robotaxi service they assume. So if they assume that the taxis are somewhere outside the city parked, and then they come pick the persons up and then go back or go take the next person, then VKT can increase. But if they assume that they are shared robotaxis, so several people use the same taxi, and there's synergy in using these services when you're going in similar directions, then some studies also say that it can decrease, but they are not that often even taking into account where the robotaxis would be at night, for example. So they only look at the theoretical need for travel and how that could be optimized by the use of the shared vehicles.
Yeah, it seems that there is a lot to be still studied and find out and piloted, because the human behavior part seems still to be missing. But you said not so much is known about this automated driving and its impacts in the Nordic context. So what do you think that would be one of those areas, or a couple of those areas, where we should definitely do some research in the Nordic context, and where does these generic results apply?
Yeah, in the Nordic context, we have a lot of these two-lane roads, and for now, I think it is unclear whether or when automation could also extend to those where there are opposing directions and complex situations for these AVs. So some research on that could be made. Of course, we can, even before the deployment, assess the impacts using simulations and other tools. So that would be something to look at. And then also in general, getting a more coherent picture maybe of those of the possibilities on motorways in different traffic situations, not only the most congested situations, and then also in urban areas. So how would automated vehicles affect traffic flow in urban areas? And for that, I think a big improvement that is needed in those simulation models, because those that are traditionally used, they have been made to to depict traffic flow in general and not so much on a vehicle level, and because the difference between the automated and human vehicles lie largely in the driving behavior. So there's first a more detailed models are needed that can depict the automated driving behavior better, and then more studies should be made in different kind of conditions.
Yeah, thank you. So a lot to be done both on the tools side and then on these like the huge part of our road network indeed is these two-lane roads, and we have a lot of these low traffic volume conditions. So that's right, that not too much was related to them. I see now no further questions in the chat box, so I would like to also thank again Elina and thank again all of our seven presenters. So I think we had a very nice setting of different viewpoints, different CITS service types with different types of evaluations done in different Nordic countries. And this is not all that NordicWay 3 has done in the evaluation. As I said, that we have a big number of evaluation studies done under different pilot activities here, and some of the last ones are still ongoing, so that we are still waiting for the last results. And indeed, in the springtime, somewhere maybe in March or early April, you will find then from the NordicWay.net website these evaluation results report, which will summarize all the activities done with the references to the original papers. Yeah, you need to learn some of the Nordic languages to go through to all the details, but maybe you can then also contact these authors to see if they can answer your specific questions that you have. Or then you used AI as Esko hinted, so Finnish is not that difficult once you have certain tools available to you. But anyhow, now we are still 5 minutes to the end of the session, but I guess no one minds if you can have 5 more minutes of break time before the final panel of this NordicWay 3 final webinar starts. So thank you very much for attending today. Thank you very much for active contributions to the chat box and for the very good questions. And we'll hear again of the other speakers in the panel discussion. So thanks a lot. Bye bye.